Good day, everyone. I'm Karthik V from Ibitech Singapore. Basically, I'm a BIM consultant. I'm supporting companies and I'm an advisor. Also, I'm a part-time lecturer in some of the Singapore university. Also, doing a lot of BIM support for project base. Today, we are actually going to discuss about scan to BIM. First of all, I would like to thank for this opportunity. Let me open the share my screen. So, as I introduced earlier, I'm Karthik V, Operation Directors by BTech Singapore. So today we are going to discuss about scan to BIM. So actually, I just picked three use cases which I already work and now I'm continue working on those areas. The first one, we are using scan to BIM for interior design. Also, we are using addition and alteration. Then we are using it for BIM facility management. Let me see in detail. Okay, the before we go into the more detail about scan to BIM, let me explain some users first. First, you understand how we can use it. Later, we can discuss about the various type of scanning and its users. So, the first one we can see scan to BIM uh, interior design. So this one is one of the project we did it using different one of the uh, scanner. So I can explain all the scanning details later. I just give you some interesting information, how we did this one, how we deliver this one. So my architect got this interior design project. Then they approach us for uh, proper 3D model based on the given drawing. Then when I come out the 3D drawing, I realize some of the things is not perfect as per the site. Then I recommend this kind of scanning to my architect. Then my architect agree for the scanning. We did this scanning. This one is considered is something like 4 hours scanning. So we just did a 4 hours scanning with one of the scanning machine, handy scanning machine. We did this scan. Then meantime, my modeler come out the 3D model based on the given as-built drawing. So what happened when we just overlay the point cloud scan, then together with the machine, together with the model what we created, then we realize around 60 to 80 percentage only matching with the as-built drawing. So actually, what we received as a as-built drawing is not exactly tally with the what they actually construct. Luckily, we have all the all the things scanned properly, so we clearly come out the 3D model based on the scan data. After after that, we pass it to our architect. Then my architect did the interior design. Then we did the 3D model, BIM model for the interior design also. Then they manufacture or prepare the all the interior things based on our dimension, whatever we come out, the sizes, everything. Then they just did it, then bring it to site. They just fix it exactly. So something like is, it looks like a, tedious process, but it's just 4 days scanning, then around 15 days modeling. and then around 2 days comparison, then adjustment another 5 days. So around 1.5 month time, we done this project. This one is in square feet. I can say this one around 3,500 square feet project consider. So actually we work it for using Matterport 3D scanner for this interior project. Quite interesting one. Then you can see some addition and alteration. This one is quite interesting project what I did. Actually, I want to highlight this one. Like this project value is for only the scanning and modeling, also amendments, everything. Is a huge project. This one is 11 plus 11, uh, 22-kilometer tunnel with a lot of exit. Something like the project name is TR286 in Singapore. It's a KPECT tunnel project. So they plan to do a water mist and surveillance system in tunnel. So actually, this one is a 24-month project, but it's a busy, one of the busiest tunnel in Singapore. We can stop the traffic for the ANA works. So first thing, we receive the complete PDF drawing, AutoCAD drawing, MicroStation drawing. The PDF also two type of PDF. One is scanned PDF, another one is exported PDF. So once we got all these information, my team started develop the 3D model from the drawings what we received from my client. Same time, we did a scanning. Actually, some part we did laser scanning. Most of the part we did the lidar scanning, especially the vehicle based lidar scanning. We capture all the information, but what we expect is different. But after we scan, we notice on the roof side is full of black dust. So it's quite difficult for us to find the particular pipelines. So we managed to get the information from the scan. Meantime, our people come out the 3D model. Then we just compare our 3D model and scan together in the model. So you can see here, this is the scan data, what we capture using the point cloud. You just imagine 11 plus 11, 22 kilometers, uh, how the file size, how big is the file size. Then you can see this is the 3D model we come out based on the extracted information POD data. So this is the two different situation. So we come out the 3D model, but remember we can get the interior. So the exterior one, we use a 2D drawing. We cut the section, and then we just assign to here. Then we come out the outer line. So we can't get the complete thickness from the scanner. I just want to highlight. Then second thing I want to highlight, if you want a complete BIM model, object model, parametric model, don't expect the uh, point cloud software will do the 3D model for you. So we have to go to the particular software. Is a contract based one. Any software, it can be a Revit, Bentley, Tekla. So we use the first one we use Revit. This one we use Bentley. So you can see here we come out the 3D model first based on the given 2D drawing. After that, we bring in the point cloud data and put it inside. Then we compare the point cloud data with our 3D model. Then we adjust our services properly. Once we done all the services properly, we adjust everything. After that, we did the uh, addition and alteration work. So the quite interesting part, this one, I go back to here. So the addition and alteration work when we do for this tunnel, we normally we allowed to do only 4 to 5 hours every day, like morning 2 o'clock to 6 o'clock, something like that. Sometime 12 o'clock to 6 o'clock, something like that. We work. So within that time, we just go to the tunnel. The traffic is blocked for some location only. So in that location, we quickly work and come out. This is the way we did 11 plus 11, 24 kilometer. So the point cloud help us completely what we are can do for the project. So we deliver everything on time, accurately. So there is no hacking things. They just our client just go to the site. They fix it exactly wherever they want. This is the way we deliver this project. So let me go to the last use case, which is facility management. So you can see the facility management here. What I can do with the facility management. Okay, the model is there. Normally, we hand over the as-built model. Why I need to do the scan and comparison? So nowadays in Singapore, this is a contractual requirement. Most of the project is a contractual requirement that how we are going to submit our as-built model for estate management or facility management, whatever. So facility management. So usually we submit the as-built model. You just imagine the handover time, the officers come and check how we what we construct. Normally, the example the lights. Normally, the officer keep the drawing and look at the lights. They just counter check only the numbers, not the location, exact location, also the distance between the lights. These are the things they won't measure always. Okay, most of the time they won't. So the numbers only they count. But now the every time when we submit our as-built model together with the point cloud report and comparison statement, we started submitting back to our clients. This is a new requirement, especially for facility management, to make sure the as-built record is perfect. Especially the true measurement. You can see the word true measurement. Then also the when it come to a commercial or industrial building, you need to we have to make sure the space allocations, asset management, maintenance, etc. So here normally last time they use the 2D drawing. um, then they manually key in the information in the Excel sheet. Now we are submitting digital data with the 3D model. Also, this scan to uh, BIM data, which is POD, for them to compare. Actually, we are the ones supposed to compare and show the result to them, whether all the objects are there in proper location. So this is the thing normally we are doing for the uh, facility management part. Okay, actually you can see the BIM workflow, how we work on this one. So the second part we can discuss about the type of scanners, what are the scanning machines we are using, what type of scanning. So the second part I can highlight to you. So now you can see the workflow. So actually you can see facility management FMS, then the BIM model. So the we get the facility management information. This one we are talking about the existing project. So we example the FMS team is already there. So we start the scan first, this side the building model, Then we create the 3D model. After that, we do the QC for the BIM model. If anything we need to update, then just go back to the scanning. After that, the model is accepted. Then we just create asset model, FM model, facility management model. How we do that one? We get the information from the FMS team, facility management team. Then we incorporate all the information into the BIM model. After that, we do the QC for the asset model also. Then is there anything we just coordinate with the FMS team, then update the model, get the information, update the model again. Once the model is accepted, or still we have any model update requirement, we may need to go for the same workflow. Then once the model is accepted, we go for final BIM model to BMS team. So this is the way we actually work. So the other functional diagram we shown for your understanding. So the point cloud data from LiDAR, we receive it, we check for geo-reference. Nowadays, they are asking all the survey with the geo-reference. So we can do the geo-reference, but based on my experience, even though we key in the geo-reference inside the 3D model when we do the scanning, after that, most of the time we may need to adjust the model in the authoring tools, BIM tools to keep it in the play proper location. So after that, we convert the point cloud to BIM model. So the convert thing is again, as I mentioned earlier, if you convert is not a object model, is not a parametric model, is just a solid only. So we strongly recommend to do the 3D model according based on the given point cloud data. Then after that we check all the georeference everything. So then the object, we send it to database, we just add the data, then we come out the final model. So this is a kind of workflow what we use for this scan to beam process. So let me explain, go into the what is scan. So first thing, before I go all this detail, I hope you understand the three use cases I shown uh, for the scan to beam. This one is really useful, time saving, quick process, even a lot of example, as I came to know some of the airport they are doing terminal 4, 5. Some terminals are really good. They have the 2D drawing, then they convert to BIM BIM model, then they use it for BIMFM. But some very old airport, even they don't have 2D drawings. In that case, they want to convert to BIMFM. They ask the team to do the scan to BIM. Then they do the scan, then come out the 3D model, then use it for facility management. So these are the things started now. I can tell you this is the future uh, value added service for BIM, but this one will be really helpful for everyone to save their time. Also, this one will be a huge business in future. So, okay, now I hope you understand what you can do with the scan. So I know I noticed I mentioned that we use the laser scanning, we use point cloud lidar scanning. So different kind of scanning we are using. So first thing is something like scan tubing. So 3D laser scanning we are talking about is a physical space or site to create accurate digital representation of it. That's all you need to understand. So we are just going to capture everything as it is. Then uh, you can understand the laser scans are very popular nowadays. So a lot of different way of scanning machine, portable units, arm-based kind of thing, long range, single point long range tracker, and even kind of Matterport scanner. So here, um, the main thing is digital capture. What we are going to do here, we are going to capture it digitally. So the point cloud, 3D laser scanning, going to capture each and everything. But I just want to highlight one thing here. 3D scanning machines is not a X-ray machines. So if anything you got a ceiling over there, it won't capture inside the ceiling. What happened here, we may need to open the ceiling, uh, then we can scan the thing, the services inside. So here, we normally um, let the contractor know, we do the scan, we do the 3D model, then we do the as built and facility management model, comparison, everything for you. But you have to open the ceiling and you have to close it out. We are not the contractor. We are not responsible for that activity. So we clearly mention. So if your people are going to do the 3D scanning, you should remember this part. Okay, anything hide, any object is hidden. If they want to scan that one, they are the one responsible to open and to close. There is depends on the people. Okay, we are not the contractor, we are BIM consultant, so we don't have manpower to open and close and take all the risk. So it depends. If you are ready to do, you can do that one. So remember, this is like a lot of project we notice that uh, this is the gray area. Uh, I heard some other contractor has some miscommunication with the client and facing problem with this issue. So be aware of that one. Okay. So the type of 3D scan, you can see laser triangulation 3D scanning technology. We can see in a little bit detail. Then structured light 3D scanning technology, photogeometry, contact-based 3D scanning, and medium and long range 3D scanner. So the laser one, you can see the image, the laser one. So it's just a laser-based 3D scanner. So use a process called trigonometric triangulation to accurately capture a 3D shape as millions of points. So remember the file size. I always say, uh, last time last time the scanning file size is small. You just remember your photograph. Last time you used to take picture in your phone no need a big storage capacity because your photographs are the pixels are really less, so the file size is really less. Now imagine one photograph. If you take a quality photograph, even you are using your phone, the file size, you look at the file size, is really huge. So same thing, excuse me, same thing happening here. Okay, the same thing is happening here in this environment. So the scanning, the quality started to improve automatically. The file size getting bigger and bigger and bigger. So millions of points is become trillion, maybe is just increasing the point size. So the file size also getting really bigger. So you should know how to separate, excuse me, the project and the setting up. So then only you can work with the 3D model. If your point cloud is huge, don't bring it to your authoring tool. Your authoring tool may crash or cannot open, or you can't rotate, you can't bring it. A lot of things will happen. So we have to clean up the point cloud, even if the laser based or lidar, whatever. Make it small pieces, then we bring in for checking purpose. Then structured light 3D scanning. This 3D scanner project is a light pattern consisting of bar, block, or other shape onto a object. So this one has one or more sensor that look at the edge of those pattern or structure shape to determine the object 3D shape. This is the second type. Then also the photo geometry one. Even some other way also we are using this one. This one is quite simple one. It's just stitching together photographs of an object taken from different angles. Something like in your walkthrough, you can see is continuous images. Then when you just play the walkthrough, all the images just combine together, then just stitching those images and through show it to you as a walkthrough. The same technology, we can use it here. Straightforward one. The animations, the animations like Mickey Mouse is running is all are same way. Millions of photographs just stretch and become cloud data, point cloud data. Then contact based 3D scanning technology. You can see that the scanning method involves physical contact of surface of the object being scanned. First, the object is firmly held in place. We have to keep that object so that it does not move. Then the touches probably moved all over the object in order to collect the detail of the object and all the 3D information that is necessary to create a digital file. So here, the almost this one, I can say the structured one, long range 3D scanner. So two major format, you can see. Then laser plus based 3D scanners. Um, then laser phase shift 3D scanners. Actually, if you ask me, the laser based ones are considered cost wise uh, consider okay, very cheap one. But when you go for the LiDAR, the point cloud maybe quite, even especially geo one, these are the things are really, really expensive. So um, I hope you understand the thing. So uh, first thing, decide what project I'm going to do. Second thing, what kind of scanning I really need for this project. Don't copy paste from others' requirement. It might vary. If your requirement is like uh, necessary requirement, you just request for the scanning. Remember, you have to pay higher. So if you is an interior, I can say laser is more than enough. No need to go for LiDAR, expensive scanning. Then the lighting is really important. Okay, when you are doing the scanning, also the points, the placement. Example, 3,000 square feet. Are you going to place going to do the scanning in different places? Example, we call it stand or we call it in different ways terms. How many times I'm going to scan? 20 times or 25 or 50 is depends on the requirement. Excuse me. Okay. Um, so you just understand the history of scan. In AEC industry, architectural engineering, construction industry, laser scanning was initially used practice in 1990s for capturing the existing condition and designing purpose. Um, After that, is quickly become a standard practice for laser scanning company, surveyor, property owner, architect, MEP engineer, and general contractor. Especially now, Two things, I'm really surprised with two things. Then we also started doing supporting those services. One of the developer asked us, one I just contact a developer as a flat purchase to purchase a house. Then they just gave us a link. When we go into the link, is a point cloud, is a laser scan. Exactly, they construct, they scan it. Then they use the VR technology. Also, we just walk into the building. Then we can go to the balcony, then see the view. So it's something like I no need to travel to that particular location to only see the house. From my place, I can visually watch the complete house. They are using the same laser technology, laser scanning. Then another one, around 1 month before, I discussed with my friend. He's looking for house, the rental house. Then he mentioned, I saw the house already. I said, did you visit the house? No, no, they passed me the scanning report. So you just understand how easy nowadays you can buy a house, you can rent a house. Even maybe in future, if you want to buy a car, you are going to another country, you want to buy a car, then you can ask them to scan that car, everything, open the boot, open the uh, whatever the engine side, or you want to see the engine or interior, everything is scanned, then give it to you. You can zoom in. Even some scanning machine, you can measure it, you can check the measurement also. So a lot of game changer, I can say. A lot of things are changing now using technology. Um, we call it uh, reverse beam. Okay, reverse beam, scan to beam. So we are calling in different terms. If you are using only for house rental and house sales, I don't think so. It can comes inside the scan to beam, but still is a scanning process. So that's why I highlighted those things. Then um, so the identification of information requirement. So this is the one just before I just highlighted. Before we jump into process of scan to bin, okay, all requirements for the desired model drawing, that is important. Is essential to identify the level of detail of your model, because higher modeling accuracy improves the reliability of the as-built beam for the intended application. And however, the higher the level of detail, the higher is the cost. This is the one just before I highlight. You can ask anything uh, to the consultant or contractor or surveyor, whoever going to do the 3D model from the scan data. Scan detail. You can ask them to model even the support, but you need to pay more. You have to understand that. Okay. Then the scan site planning. Okay, scan planning is a setting parameters before the question of a 3D scan. So first thing, um, yeah, we actually, as I mentioned, to find existing document for building is might be difficult or not available, or some only available. So the scanning machine going to support us to get the information to come up with the 3D model. So you can go for accuracy, space resolution, coverage, other attributes like location, angular resolution, etc. So the scanning side, the capturing the reality, scan to beam function with the help of 3D laser scan, which collect the data which high speed and precision. The device have an eye safe laser rotating at high speed. So I can give you an example based on this one. Around 100,000 square feet. Okay, we just did it in less than a day. So it depends how fast your people can do, then accuracy, even the number of strands, like how many times you are going to scan, whether the distance you are going to do, uh, 10 feet once or 5 feet once. Okay, it depends, but but still you can do at least 100,000 square feet in one day. So this one for your easy calculation, how fast you can do the scanning. Then um, so you can look at the point here. It is generally placed on the tripod, okay, at the side. So this is not for every scanning machine. Most of the scanning machine, okay, they use the tripod. A lot of few scanning machine, we just on it, we just run, we just walk behind the scanning machine to avoid to capture our face. So it will capture all the non moving object. Sometimes it will capture the moving object. So few times we are going to scan in same location. If the object is appearing and disappearing, is just removed from the uh, scanning. So it will be easy to clean up the unnecessary information before we compare with the actual 3D model. So you can see, if you can use a 360-degree scan, you can use a time of flight scan, even drone scanning also. People are using exterior. Um, so is a time-based flight scan they are using uh, for this kind of scanning. Then the last part, 3D modeling as build ready for the new build. So the final stage of the scan to BIM process is convert accurate point cloud scan into a 3D BIM model with the as-built condition of the existing building. So the scan building, the technology is already is going bigger. I can say before around 6 years, 7 years before, people spend around $300,000 to buy a machine. Uh, now you can easily get the same kind of in high quality machine. Also, you can go for $100,000. But even the laser scanning machines start from $4,000. Now there is a uh, artificial intelligence scanning. I'm just touching that one for you to understand. The camera is fixed in the helmet. Then all the engineers wear it. When they walk around the side, it will capture everything, whatever they construct, whatever the things in progress, everything. So that's the way they are capturing the information. Is one of the latest technology I'm just highlighting. So some example here, how the scanned image and the BIM model looks like. So remember, we no need to wait uh, until the scan images we receive to develop the model. Uh, if you have the 2D drawings, better you develop the 3D model, then you come out the uh, once you come out the scanned images or scanned point cloud, you can compare with that one. That is the best workflow. That's all from my side. Thank you very much, everyone, and stay safe. Keep in touch. Thank you very much.